In 2019 Toyako meeting, I had a talk on seismicity read around the Taiwan and Ryukyu Trench. I would like to represent the talk as a start point. The HERP map shows the updated National Seismic Hazard Map. Here is the schedule for the seismic hazard assessment in the long-term evaluation. Courier Trench E area was done in the 2003 and to the 2018, where is eastern Hokkaido. For the region C, it took 19 years for the reassessment of the region C, whereas the south region of 2011 magnitude 9 earthquake area. The pink area A was done in 2013, where is Nankai Trough. You might see all of Japan trenches are pink, but not Ryukyu trench, where is the nearby the Taiwan with the question mark. Seismic activity issue raised because of two reasons. One is unexpected magnitude 9 earthquake in Japan, and the second one is Taiwan also has a possibility for a large earthquake. We'll talk about the zoning method and the non-zoning method, and large uniform area source used for seismic hazard map for Japan, and the uniform area source for the Taiwan. Then we'll mention the combination of large uniform area source for the Ryukyu and the Taiwan. Japan Trench Seismic Hazard Assessment in Long-Term Evaluation from Earthquake Research Committee, HERP. It shows the assessment history for region C area for the year 2000, PSHA in long-term on Miyagi-Oki earthquake. The second modification after 2011 earthquake, Tohoku earthquake, in the 2019 seismic hazard assessment in long-term along the Japan Trench modification version 2 is done. Taiwan Islands, located on the south end of Ryukyu Trench and north end of Philippine Trench. From this ocean topography, we could easily understand that Taiwan Island is very complexly joined between the two trenches. Earthquake activity on both trenches affected the Taiwan Island, considering uncertainty of seismic hazard assessment. Area play very important role in the PSHA. For this square area, here is the 10 years seismicity around Taiwan from 2009 to the August 8, 2018 by GMA information. Eastern Taiwan is the highest seismicity as shown in the green dot. The bottom figure shows the magnitude larger than 6 from 1994 to 2019, include the Chichi earthquake. The square area is the very active earthquake area. There are many people contribute to this area earthquake activities. Based on the Nakamura Sunagawa 2015, we knew the absence of very low frequency earthquake indicated by the red circle, the repeated slow sleep earthquake followed by the pink rectangular, locked area by the orange rectangle. The area of distribution tsunami borders by green ellipse. Rupture source of 1771 Yaeyama earthquake by the yellow rectangle. Of course, many works from Taiwan, for instance, Xiaoru et al., 2012, did detailed seismicity about this area. I'm very happy to see her join the meeting. Seismicity is magnitude large 4 from the central WBT. Start denotes the historic events with magnitude larger than 7. The rectangular denotes the potential rupture fault along the Ryukyu Trench. The bottom figure shows clear image of subduction down to the northern along the section A'. In Japan, 29 zoning were divided based on seismotectonic subduction zones epicenter distribution. Earthquake catalog is most useful for the regional classification and frequency estimation of the earthquake. The green polygon is the areas I'm going to talk. National seismic hazard maps for Japan use two kinds of GMA catalogs. The medial-sized earthquake catalog in the left side with over 140 years, magnitude larger than 6.0, and the small-sized earthquake catalog with 28 years, magnitude larger than 3.0. In additional 29 zonings, an alternative statistic way to reduce epistemic uncertainty was used for national seismic hazard maps for Japan. Left figure, large areas are combined by the thick line as from L1 to L2, L3, and L4. Ryukyu Trench is L3. Right figure is the epicenter distribution. Declassified instrumental seismicity by the median earthquake catalog of magnitude larger than 5 since 1926. You might see the difference with the small size earthquake catalog for magnitude larger than 3 since 1983. There are various ways to consider the annual rates of occurrence frequency for earthquake without the specified source fault. We use average of zoning seismicity as the top left figure and non-zoning seismicity before the magnitude 9. After magnitude 9 occurred, average of them with the non-zoning large seismicity is used as the bottom figures. Here is the earthquake occurrence frequency in Ryukyu region L3 and Yanaguni-jima. Left column by the medium-sized earthquake catalog by the small-sized catalog. The GR relationship line with p-value of 0.9. Maximum magnitude for Ryukyu Trench is 7.7 on 1938 earthquake, and for the Yonaguni, magnitude 7.3 and change to 7.5 and 7.4 respectively. There are differences about the depth of earthquake. Depth in the 60 kilometers is roughly boundary to identify shallow earthquake in both Nansei Shodo Island and Yonaguni. Earthquake along the Philippine Sea Plate with depth 60 kilometers to 150 from Kyushu to Nansei Shodo Island as shown in the green and blue dot. However, the subduction boundary is not clearly identified, so that earthquake shallower than 100 kilometers are used in Yonaguni-jima. This might be different with team model definition. By Taiwan earthquake model, the 38 seismogenic structure defined by Xu et al., the 28 areas south were divided by 1 et al. 2016 as the blue line. The T0A is the plate interface of Ryukyu arc subduction distance. The depth is from 10 to 45 kilometers. 1922-20 Hualien earthquake magnitude 8.2 was the largest earthquake in this region in past 100 years. By Chang et al., there are 28 area sources as left figures, and the table gives the GR parameters and recurrence interval of magnitude larger than 6.96. As the alternate way to reduce the epistemic uncertainty, averaging the annual read of Taiwan Islands with that of Ryukyu Islands L3 by Jesse's result. The annual read is ranged from 10 to the power of -4 to the -2, and ranged from 10 to the power of -3 to the -2 in the Yonaguni-jima. On the other hand, team has a different result of annual read in about the same area as 14C, 10 to the power of -3. We knew the existing difference and the proposal to work forward to have reasonable annual read in the future. Here is the ongoing work on her PSHA processing. The blue line indicates the existing seismic zone island plate, which is based on existing knowledge. Red stands for the reclassify and supplement seismic zones. Outer-rise earthquake will occur in the outside of subduction zone. Red line is set up by a kind of judgment or likelihood. The green line shows the depths of ocean plains, Philippine plains, and the Pacific Sea plains on top surface. This slide is just added that we are going to discussion. The trench axis as shown in black dashed line. Ryukyu Trench is divided two ranges, shallow in the south part and deep in the north part. The west edge ending in blue line for the 2020 version of Yonaguni Island is the edge of Yonaguni Island ending in the yellow line or in the red line, including Taiwan Island. For the detail, Morikawa-san will have more new information. As a summary, average seismicity read by the zoning method and uniform method is an alternative way to reduce the epistemic uncertainty. Large uniform method after 2011 Tohoku earthquake used in seismic hazard maps for Japan. Seismic activities around the neighboring Taiwan Ryukyu Trench are a significant issue. We propose a super large geotectonic area that covering Taiwan and the Ryukyu to mean the annual read for the both national seismic hazard maps. Finally, the promotion is needed for the further Taiwan-Japan cooperation for the PSHA around the Taiwan Ryukyu Trench. Thank you for your attention.